tricky to me.
Yeah, 8s and 7s are the ones we usually save for last.
Except if it's like 8 times 9 or 7 times 9.
All right, but no, see, and wasn't it kind of fun where you got to finish first, right? And that's what I mean. 9's super easy, super easy.
Attention to the screen, okay?
We'll do this real quick. It's okay. You'll be all right. Now, because it always adds up to 9, right?
Yeah.
So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. All right, let's just do it for fun. Take out your tray and build me 9s and 10s. The trick, again, this is not hard. This is way past your skill set. The trick is to warm your brain up. So just use 2 hands. The trick is to use 2 hands, right? Not use 1 hand. There you go. I like it. I like that. See, and that's really good for your brain, actually. Yes. So I just got done watching. I'm going to send you a link out of all. I only have, you would be like the only one. Actually, there's one other, but she, we won't talk about it. But anyway, the idea is that that thing you sent me. Yeah, I'm going to watch it again.
That's amazing.
Yeah. No, because that's what we're starting to figure out. That, yeah, with this technology, we should be getting minds together.
Yeah.
And see, all those people are pretty well aligned, but some of that stuff was new to them, right? Because they didn't know each other's work and so forth.
Right.
And like I said, like that one lady, I'm absolutely gonna go get in contact with her. Yeah.
Crazy.
I mean, I like it. He's done a good. Actually, you know what? I should take a picture. Of course, by the time I get a picture, he'll be done. Wait a minute, you're supposed to do 2 hands. See what I mean? You're doing 1 hand. You're already. I see. You did 1 hand with one, and then 1 hand with the other. Okay, I'll take it. That's actually true, right? Because first he was using his right hand, now he's using his left hand. All right. Both at the same time is probably better, but it doesn't matter. We just want both hemispheres going, not just one hemisphere. All right, how's that? Okay, and now you can see, look, there's your 9s. Right, Jack? Yeah, there's a 9, there's the, right? The 18, the 1 and the 8, the 2 and the 7, the 3 and the 6, the 4 and the 5. So you can see the representation there in the tray. Okay. So anyway, that was excellent. All right, let's do 7s and 8s then, since you said, and I agree. Let's do 7s. We usually use 7s for last. Okay, so have you watched Lucky 7, Samson?
Yeah.
Okay.
Wait, what is that?
Multiplication rock.
Oh, yeah. Like when they all go in order?
Mom has something mess with your mind.
Stop it. All right. Count for me by 7s, young man.
Wait, what?
Count for me by 7s.
7, 14, 21, 28.
Yeah, there you go. Got right. What's 8 and 5?
36.
Wait, hold on. I'll help you. Look over here. Just put your food down for a second and grab a 7. Just 1 7. You just need 1. Okay. So 7. What does 7 need? It needs 3. So 14, because that's actually now 2 10. And then what? The 4 needs 6. So then 21. Oh, and then the 1's going to be all unhappy because now we have 8, right? Because it wants to have a 9, but we're only going to give him 7. So we get 28. Now 8. What does 8 need? It needs 2. So, if it's 2, what's left there, Jack? Look down on yours.
5.
And cover 2. Cover 2 with your fingers.
5.
Yes.
So what is the next in line?
So that'll be 35. Then what? Well, then I'm going to 5. So I'll cover 5. What's going to be left? Wait a minute. I cover 5.
Cover 5. 2.
There you go. Then what? Is the 2 going to be happy? The 2 is not going to be happy because he wants 8 and we're only going to give him 7. So that's going to be 49 because I hope you're going to add 2 and 7. Now what? Oh, 9. What does 9 want? 9 wants just 1. So I cover 1. And you know this is going to be what? 6.
6.
So that's 56. Now, what is a 6? The 6 wants 4. So I cover the 4. And what do I have?
3.
So
3.
63.
There you go. And then the last one, we know 3 is going to be all happy. Right? All right. Now, Jack, you got to have these so that you can answer these. What's 16 times 7? Well, that's going to be 70.
What's 6 times 7?
42.
There you go. Now all you got to do is this.
What's the sum?
What's 7 plus 4?
7 plus 4, 11.
There you go. So it'd be 11 tens and the 2. 7, right? So 7 16s is 112. Make sense?
Mm-hmm.
And one more time, this is why we spend so much time on the add-ins. So when you're with your daughter and your other boy, that's why we spend all that time on the add-ins. Right? Because it makes everything else easy. And see, I've got a 16-year-old in the class that was just before you. This doesn't come naturally to her. She doesn't think 7 and 4 is 11. She has to think about it. She's gotten a lot better and a lot faster, but it's just because she never did before, right? It's not because she's stupid. It's not because she can't do maths, because nobody ever showed her. Okay. And this is the other thing. I was giving unsolicited parenting advice to the other woman. She didn't appreciate it. Anyway, or actually she did, but she didn't, you know what I mean? She humored me. Let's put it that way. But the idea is that when you're doing these with Henry and with, what's your younger daughter's name again? Kira. Yeah. This is the time for state capitals and the names of the states and the provinces of Canada and their capitals and the provinces of Mexico and their capitals, because this is the sponge time. And that's just rote memorization. And by the time they get to be Jack's age, they don't want to do rote memorization anymore. They want to play and do other stuff. They want to think about the stuff that they've learned. But up until about the age of 7, that's the time to stuff that kind of information in. World facts, geography, math facts, obviously. But that's the time, right? Chemistry. You can get them to memorize the periodic table. By the time my boys were 5, they knew their ABCs. They knew all their numbers. They knew square numbers. They could do the Greek alphabet, right? The teacher was, right? She was like, what the heck? Okay, why? Because they're 5. We just played. Right, we didn't, and all Greek alphabet was just them repeating alpha, beta, delta, epsilon, right? Phi, chi. I mean, they were just repeating it. But then the next thing after, just like this, 7, 14, 21, 28, 35, 42. How many is that, Jack? 42.
6.
There you go. See, you shouldn't have to think about it. You got it fast though. But and also, did you notice his eyes? Right? Getting the information. Okay.
I memorized 6 times 7.
Good. What's this one? How many 7s? See, look at you counting, please. If that's 10 of them, what's that one gotta be?
9.
9. And Jack, 6 and 3, 9. You know it's a multiple of 9 if it adds up to 9.
But it only works for the 63, 42, and 21.
What do you mean? You saw that. No, I wasn't saying that 4 and 2 is 6. Just so happens.
Yeah, and so happens 6 plus 3 is 9, and so happens that 2 plus 1 is 3. Oh no. Well, yeah, 3.
Yep, there you go.
6 and 9.
So let's see here. This is free. Oh, 3, 6, 9. Oh,
2 numbers in between.
Oh, and then what's this? 5, 1, 8, 4, 1. Oh wait, sorry, that's a 2.
2.
Right?
So
and then what? Okay, and that's 7. So let's see here. 5, 3. That's 10, but it's a 1. That's 8, 6, right? That's 13, but 1 and it's 4. And
Yeah.
11, 10, and that's 7. Oh, just for fun, Jack.
Please look at the screen.
Do you see a pattern in there? In fact, do me a favor, grab your paper and pencil and write this down. Just for fun. And then I'll keep going. 77, 84, 91, right? Because it's just 70 plus 7, 70 plus 14, 70 plus 21, 70 plus 28, 105, 112. That's where we quit with Lucky Seven Samson. 119, 126, 1. What's that? What's that going to be? 133. Oh yeah, because it's going to add up to 7 because 19 times the number is always the number, and that'll be 140. All right, so let's see here. According to this, it looks like 753, 18642, 9, and we're back to 7. So if this is correct, this should be 5. Oops, pick a different color. And I'm just having fun, by the way.
Which it is.
Do you think that it should be the same, Jack? I think it's going to be the same. Let's see. 7, 5.
Do you understand how he gets the 5?
1
plus 7, that's 14. And then
right?
he has 1 and
8, 6. Oh, look at that. 4. Oh, look at that. It's 2. And the next one should be 9.
Say yes or no.
I don't really understand.
You don't
And then
really. Can I please show you? You need to speak up if something doesn't make sense. That's what the lesson is for.
there you go. And I just got done telling my other student, just because the teacher says so doesn't make it so.
4, 5. This is just collapsing to the smallest number.
Okay.
So if you collapse 7, that's a 7. 1 plus 4 is 5. 2 plus 1 is 3. 8 plus 2 is 10, but 1 plus 0 is 1. 3 plus 5 is 8. 4 plus 2 is 6, right? That's just collapsing. Or whatever, there's probably a term for it, but
The digit sum.
digit sum. Oh yeah. Okay, sum of the digits.
Yeah, the sum of the digits. All right, but you see, and then Jack, just for fun, you could do the next row and see, does it work out? Even though the numbers are starting to get big? Because what's the next one going to be? 147. So now you're going to add 7 to 140, 14 to 140. 50. Anyway, do the next row on your own time. All right, can you do the donut factory? Can you do this over here?
Let's do a new page for it.
Oh wait, did you finish copying this?
Yeah.
Okay. So can I can erase it is what I'm saying. Okay, we are recording. Did we not start? I'm sure I started. All right. Can you do this problem?
You can say no.
You can say yes or no. Do you need help from Mui?
No, I can't.
Yes, you can do it, and yes, you need help. Just say it.
Yeah.
Yes, you need help with this.
All right. So what are we going to do? What's the first thing we're going to do when we look at this problem? So here's what happened. I sent Mui off to the donut factory, and he was supposed to come back with the information, right? And if he would have got there when it opened, we would know if there was any donuts in there to begin with. But he didn't get there when they opened. He didn't get there till 5 hours later. And after 5 hours, there was 42 cases of donuts in the factory. And after 8 hours, there was 63 donuts in the factory. That's more than enough information to figure out how many donuts they're making each hour and how much they started out with. That's all you need. That's pretty cool when you think about it. But that's more than enough information to figure it out, Jack. Figure it out.
No.
What are you going to do? No. What are you going to do? Well, here's the first thing.
Pay attention.
Can you tell me the difference between 5 and 8?
They're just 4.3 apart.
3. What's the difference between 42 and 63?
42 and 63. Very different numbers.
JAQ, subtract 63 from 43.
The other way around. 42 from 63. But yeah. Oh, come on. How hard is this?
On
What's 3 minus 2?
21.
All right.
By the way, you are so
Now, 21. What is this? The difference in y's, the difference in, and we're expressing one number in terms of another number. Remember that?
Yeah.
So I could say that this is 8 5s and 2, right?
Yeah.
But I can't say that this is 8 8s and 2 because 8 8s is already more. So that can't be right. So let's try the other way around. What's the most 8s I can get out of 63? Also, you have to remember,
Seven.
especially you, Mom, you're running beta. He is
I
only
know.
just barely running beta.
I know, but to get him to even running, that's what I'm trying to do.
8 times 7, 56.
I like it. So it has to be 7 because if you do 8 times 8 is 64.
Is that how you got to it? You got to 8 and then 1 down? Smart.
Okay. Yeah. Very good. Okay. So let's see. So that would be 7 8s would be 56 and 7, right?
Mhm.
Okay. Well, let's try this over here. 7 5s and oh yeah, 7 5s is 35 and okay, that worked. But the easier way to do it is the difference in x. That's this right here. It'd be called dx. We're really creative mathematicians. We don't write out difference. We just put dx. The D stands for difference. And then dy, the difference in y's. And dy dx gives you rate. Right? Rat E. It also gives you slope. Right? When you're doing your graphs and so forth. This will tell you what it is. All right. So all we're doing is a constant rate problem. And if I did it this way, here's the other way I'm going to have to do it. All right. What's 21 divided by 3?
21 divided.
Repeat. Just get to it.
7.
What is it?
7.
It is 7. All right. Now, look. What's 7 times 8?
7 times 8, 56.
All right. But it's not 56. It's 63. So how much more would I have to add to 56 to get to 63?
7.
7. All right. 7 times 5 is 35. But it's not 35. It's 42. Yep. I have to add 7. All right. So now I know that the amount of time it takes will tell me how much there is. And this is my function. Right? And the function is the number of donuts in the factory is equal to 7 donuts an hour plus 7 to start. So over here, I know at 0 hour, 7 times 0, they started with 7 donuts. Right?
Mm-hmm.
Or all 7 cases of donuts. Now, here's advanced what's under the cup. How many hours are they working if they have 77 donuts?
You have 7 cups. Then you have a 7, and then this is 7 to 7. Can you remove 7 from each side?
Yeah.
What's left on this side? 7 cups.
Yeah.
The
And
fourth
then
is gonna have
70.
70. Good. You have 7 cups. So how much is each cup? 7 cups, and you have 70.
77.
No. 7
Wait,
cups.
look over here. Look over here. Your mom got you to this point right here, right? Because she took 7 from both sides. Please, what's that got to be?
Wait, 7 times 70.
No.
7x equals 70.
10.
That's just him not reading the symbols because he hasn't seen the symbols. So yeah, it has to be 10. That's why your mom was getting vaguely frustrated because it was such an easy number. But the idea is 7 times 10 is 70. Okay, let's do something else. What's that?
Just did.
Can we play like
We were just playing what's under the cup.
with cups?
We don't have, we actually have as many cups.
Here
as-
I did. I hate to say it, but you're like almost too big to use cups. But see, this is the thing. He's 9. Playing what's under the cup is fun. So here's what I'm going to tell you. Play what's under the cup with your brother and sister.
At the end, right?
Yeah, at the end, after class, call your brother or sister in and we'll play some what's under the cup. I agree that what's under the cup with cups is more fun than playing on the board. Absolutely, this is true. Okay, let's do some factoring of polynomials.
Okay.
And then we'll do some super duper cool what's under the cup. We're going to find stuff that's the same on both sides. All right, so grab your x squared.
One job.
And I'm going to do, okay, we could do it two ways. I can give you the whole square and you tell me the sides, or I can tell you the sides and you tell me the whole square.
You tell me the side, I tell you the whole square.
All right, let's do that. I like it. And here's how we'll do it. We'll do it 100% random. This is my dice right here, right? Multi-side dice. So we'll just roll it in here. All right, so first number is going to be 12. Second number is going to be 17. All right, so I'm going to convert this into algebra, and I'm going to say x plus 2 times x plus 7. You build it.
Where are your x's? Pull out your x's.
Yeah, put 2 over there, and then put 7. What?
You know how to do this, grab one.
Yeah, he absolutely knows how to do it. And this is why I like multi-tens. Man, if you can find some multi-tens, it would be great. All right, 2 there and 7 on top. So the rest will go on top. Beauty. And now tell me, oh, you want to get your 7s out just for fun, or do you need them?
I don't need them.
Yeah, we put them in there anyway just for fun. All right, tell me what it is. You got it. You're absolutely correct. Tell me what you got.
1x squared,
Yep.
9x, and 14.
I like it. Now, what would be 12 times 17? Wait. Watch. Jack, watch. 100, 90, and 14.
100, 200,
Mm-hmm.
4.
There you go. Done. And it looks like this if I was going to draw it real quick. Boom, that's 2. Boom, that's 7. Boom, that's 14. Right?
Mm-hmm.
Okay. Fine job. Another one. Okay, no help from mom. Oh, 16. So x plus 6. Oh, x plus 6 squared. And this is how I'm going to write x plus 6 squared, which would be 16 squared. Go. That's you.
Go.
I love it. Yeah, because you're going to need 6 and 6, which is why your mom showed you the bottom. Hurry up. What are you doing? Build it.
You don't know what to do. It's okay. You know that you have to start with this. Now,
Right.
how many?
What? You need 6 on each side.
Remember when you start with that and you don't know that you even need this? You just need an X. You know that this is always an X, and then you need a 6. Hold on. I'm not supposed to help you, but
I know what you do.
right? And then you at least draw it this way, and then you'll be like, well, on this side you only need 5 because you're already utilizing 6. But that's basically your. That's
I like it. I like it. And then just fill it in. That's one way to do it. The other way to do it is just put 6 on each side and hurry up is what to do. Just grab 6. And see, this is why. This is why I like to have multi-tens, is because you can just grab, except I don't have any multi-tens handy. Oh, there you go. You can just grab, boom, and you got it, right? You don't have to take out 6 of them at a time, right? Because, oh, look, it's 6.
Not that I showed you.
All right, so put 6 there and put 6 on the other side. Yes, both sides, put 6. Just put 6 on each side.
256.
256, good. Build it anyway. Build it anyway. I like it. You are correct. It's 256. What would it be? This would be 256. What would this be?
You have to speak.
If he doesn't have to build it all the way, I'm even happier. Tell me.
X squared,
Yep.
12x and 36.
Fine job. X
Wow.
squared, 12x, and 36. Woohoo! Jack's doing math. Woohoo!
You sit here and tell me you can't do it. Seriously, no? Don't use that word.
All right, there you go. Can't. Yes, get that out of your vocabulary. I was also dressing down my 16-year-old because she's like, I can't do math. I'm like, you're doing math all day long. What are you doing? And if you can't do math with me, you're kind of screwed because I'm the best math teacher in the world. So. All right. You ready for a toughie?
Yes.
You
You can.
You can do it, Jack. You can do it.
I need something to fiddle with my hair.
Okay, if you still pay attention to this.
Are you going to ever compete in the Olympics? Because you're never going to compete in the Olympics with an attitude like that. Anyway, so
Olympics ruins your life. No,
I actually would agree with that. I know I trained for the Olympics actually, and I knew a bunch of Olympic swimmer. I was a swimmer, and I know, yeah, they're crazy, right? I was going to get a scholarship at University of Hawaii at Manoa
Wow.
for swimming because I was a state champion and everything. And I looked at the program and I was like, I don't know how I would be able to go to school and I could either be a swimmer or go to school, one or the other, right? And that's what I mean. Those athletes, I give them credit because there's one girl, engineering student and a swimmer. So she was doing long course. So you get up in the morning and get in a freezing pool and you swim for 2 hours, and then you do weight training, and then you run, and then you get in the pool in the evening and you swim for another 2 hours, 6 days a week.
My
I was
God.
like, I'm not doing it.
No childhood, no younghood.
Yeah. No, but I mean, like I said, University of Hawaii has to this day, they have a pretty stellar swimming team.
Wow.
Them and San Luis Obispo. Anyway, let's do X plus, talking too much. X plus 4, you could have been building this while we're going. Oh, easy.
4 on each side.
Boom, done.
Just think, okay, it has to be an X plus 4, and then the other side.
Do you even need to get the blocks out? Really? Here, wait, I'll do it really quick. Watch. Boom. Bam. 1, 2, 3, 4. 1, 2. Boom. Do you really need to get blocks out? Or can you just see it in your mind?
Over here is 16.
I like it.
And
Wait a
then
minute. 16? Where are you talking about the 16? Oh, I see what you're doing. I see what you're doing. All right. But look, it's just X squared.
Are you doing this?
How many X?
Lost.
How many X? Here,
Look.
rather than doing it like that. Okay, there's that.
8x.
How many X?
No, it's not 8, honey.
Yeah, count. Look in front of you. Put your X square in there. Your mom did everything for you. Just put your X square in there.
4 right here and 4 right here. That's 8.
It's not 4. It's X plus 4 and X plus
Oh, he
2.
was thinking. Okay, what he's thinking is that it was X plus 4 squared.
That's what he was
4 times X plus 2. Yeah.
Do you see? It's X plus 2 on the other side. That's why I only 2.
Yeah.
Do you get it now?
Yeah.
Yeah.
Okay. Go say what they should be. X squared plus how many X's?
6.
Yeah.
Yep.
Plus.
And
8.
yep. Okay, so what's my number?
Sum this up. 100.
168.
I know there was not anything dynamic about this one. Didn't have to carry. Didn't have. You got 100, 6 times and 8. All right, let's do another one. Yeah, it's 100% random, Jack. Well, not 100%, but anyway, as random as I can do it with that. Okay, now I'll give you. How about this? How about just 15 squared? You should know this off the top of your head.
That should be a question. What are my X's? And then fill in the rest. Okay.
Yeah, there you go. Or just put 5 on each side. But anyway, what's 15 squared?
15 squared.
Think about it. See if you can do it in your head.
Well, you have 100, which is a 10 by 10.
Yeah.
5. So that's 10x.
5.
Plus, what's in between? 5 times 5.
3.
5 times 5.
25.
25 here.
So here's what your mom's doing. She's saying, look, here's your 100.
Got 3 from 5 times 3.
Here's 5. Here's 5. and here's 25. These are tens, right? So what do you have? 100, 225.
Do you see that or not? I need to make sure you do. If you don't, we'll do
Yes.
it again.
Yes.
And that's the thing. You can play more than 1 hour a week with me. This is like your master class, and you could play another time. And like I said, Jack, with your brother and sister, I know they enjoy playing What's Under the Cup. So you should set some ones up for your brother and sister, or brother and sister, right? And the idea, Jack, too, is when you do it for your sister, make it so that like it's just like tens, right? To start off with, super easy. Like 7 in the cup, 3 outside, 10 is the same as 10, right? 5 in the cup, 5 outside is the same as 10. 2 in the cup, 8 in the right is the same as 10. Just for your little sister.
Right.
And then you can get more.
Yeah.
Do you have to go to the bathroom or something?
Yeah.
Okay, go. Take off. Take off, eh?
Quick. I'll be quick.
All right. Yeah, be quick. Be fast. Take your time going, but hurry back. Anyway,
You see, half of it is not math. Half of it is just getting attention to the question.
yeah, and this is the other thing. Yes, it's not. It's a 9-year-old, and again, he's not making beta waves, so he can't think as fast as you can or I can.
A 7-year-old can see the question and recognize it.
Yeah. Yes.
without being
And
lost.
that's your 7-year-old, not your 9-year-old. This is the thing, right? I got 2 boys, born 18 months apart. People thought they were twins. Completely different humans. Completely different humans. And then this is the thing too. Like I said with Jack, the processing speed is still he's 9, but he's still probably doing quite a bit of theta and alpha, right?
Yes, but then he's calculating this 200 something in his head, and I was still not even there, and he was already there. So,
yep, yeah, that's it. And that's the thing too. Even that processor running at alpha is still crazy fast if you train it right. Because I have little boys. You know that problem that I put the first problem we did that was the right the
rate constant rate.
Yeah, constant rate problem. I have little boys, 6, 7 years old. They look at the problem, they tell me what it is. They just look at it and they know it's
right.
Yes. Okay. But that's because they've been fooling around with me since they were 5.
Wow.
Right. Okay. And then I had a couple of ones that were actual geniuses, where the first time I saw it, they just knew what to do. I didn't even explain it to them.
Wow. That's very cool.
Right. And it is. And that's the thing. I have other ones where you teach it to them, and the next week you got to teach it to them again because they forgot. They honestly don't remember what they did a week ago. Okay. Right. So you meet them wherever they're at. This one is, yes, attitude and attention is part of it, but it's also the fact that you have a quick mind and his mind can't keep up with you. It's like impossible at this point. When he gets older, maybe. But right now, like I said, he's probably burning mostly the way I see him operate. He often will fire the brain up. That's why we do the warm-up exercise and get into alpha. But it's almost impossible for him to make beta because he's only 9. He can't. His brain isn't there yet. 3 more years. And this is why keep the dang sugar and red dye and all the stuff out of the injection, all that. Keep it out of him because it affects the brain, and that'll affect him for the rest of his life. Right? And I have parents where I just want to wring their necks because they're poisoning their kids with food. And that's when that's not a son or a daughter, that's a kid, because you are following the advice of what we now know are satanic pedophiles when it comes to feeding your children. Don't do that. A bad idea. Anyway, and see, it's no longer crazy talk. We can actually say the words out loud. 10 years ago, I was an insane person because there's no such thing as a satanic pedophile.
Now everybody knows. So
everybody knows, including the Iranians.
Like, let's do a war, or let's do this, let's do that.
Exactly. Yeah, we're recording, so let's not. But at the same time, yeah, people have started to figure out, yeah, my sons and daughters are going off to die for satanic pedophiles. Yeah, you don't want that.
You scared me. Can you close the door, please?
Yeah.
Appreciate it.
And by the way, they just tried to kill you.
There for a long time.
Oh, okay.
That just minor detail. They just tried to get you to kill your children and yourself. Maybe it's a bad idea to follow their instructions when it comes to war. Just saying. Okay, little boy.
You
Okay.
Oh, look, picks up his book. What is it? Oh, what book you got? What book you got? Oh, I love it. Okay.
Give me eyes. This is a math lesson, okay?
No, it is a good book.
really great.
All right, you. Yeah, really? Oh man. Okay. So, Jack, do me a favor. Count by square numbers to the best of your ability. And actually, let's build a pyramid just because we can. Do we have time? Yes. You have to be fast. You have to be fast. So start with your 9. Okay, there's your 100. Then get your 9s. Then get your 8s and so forth. And let's count them. So we'll go backward. So we're going to start with 100.
Not just build.
What's 100? 100 is a 10 square. All right. Then what? The next one's going to be 81. And that's going to be a 9 square. Anyway, you do it. You count for me. Yeah. So
What's
there's
eight?
your 9. Go. Keep going.
8 times 8?
Yeah.
4.
Excellent.
You can build it now that you said it.
Yep.
What's 7 times 7?
Oh, wait. You only need 8 of them, Jack. And then, well, let's see how he does it. Cross hatch. Yeah, go the other way. Go the other way.
Go this way so that they stay.
Yeah, so it goes like this. When you, that's a building technique. If you make them all the same, it'll collapse. But if you build it like that, it's more solid.
Square them up for you, but you have to do the math. So what's the
There you
what's
go.
7 times 7?
49.
All right, get the 7s. Do the rest.
Square them
You
up.
give me such excellent pictures.
Go get the 7s.
Yep, get your 7s. Oh, are you gonna center it or are you gonna put it on the side?
Side.
Okay.
I need one more 7.
There you go. And what number is that gonna be?
What's 7 times 7?
49. I already said.
Excellent. Oh, I didn't hear you. Sorry. All right, 49.
All right, what's 6 times 6?
36.
Got it. What's 5 times 5?
25.
And then what's the next one? 16, right?
4 times 4?
16.
And then what's 3 times 3?
9.
And then the last one will, of course, be 4. Well, actually, the last one is 1 when you get right down to it.
4 times 5.
And then we can, just for fun, see, I'm starting to find out prime numbers have a lot to do with how this simulation works.
Mm.
And I was fooling around with prime numbers, and now I'm going to start actually at the ripe old age of 62, memorizing my prime numbers.
Okay, remind me, what's prime numbers?
Prime numbers can only be divided by itself in 1.
Oh,
Like 5.
5 is prime, yes.
okay.
And that's the thing you could do with JAQ for fun. Figure out prime numbers up to like 100.
Yeah, wow.
Just for fun.
Also 1. I think.
Right? Because a lot of people think is 31 prime. Well, yeah, yes, it is. Is 32? Nope.
Yeah.
Right? Is 45 prime? Well, heck no, it's not prime. You can divide it by 9, you can divide it by 4, or excuse me, 5. You can divide it by, right?
Yeah.
15. Because you can divide it by 3. Oh, I like it. That's an excellent way. That's an excellent way. That's a good technique. Look, a cooperative building technique. I like it.
Just figured out something in fraction form.
What?
If you were to build 4 of these, this would be 1/4, and it would be an entire pyramid.
Yes, that's good.
Hmm.
See, and that's the other reason. Just play with blocks and they figure stuff out. Did I tell him that?
No.
There you go.
Press your 1 and then you're done.
And then you are done. Okay, let's do a quick, let's just for fun. What's the digit sums? What are the digit sums? Let's see. 1, 9, 1. Then what?
All right,
Figure that out.
No, what's 9 plus 4?
9 plus 4 13.
What's the sum of the 1 and 3?
13. 1 and, right? So 4,
4.
1,
9. Wait,
7.
isn't 3, 6, 9?
Oh. You're correct. And then what? 7.
6,
7,
7,
9,
1.
4, 1.
Lots of 9s, 1s, 4s, and 7s.
Yeah, I think we got to go. I think we might have to. I think we should go this way. 1, 4, 9, 7, 7, 9, 4, 1, 9. Well, let's do the next one. Well, I know the next one is 121.
We can't see that part though.
11 squared.
Mm-hmm.
Okay, and that's going to be
4.
oh. Will the next one be 9?
9, yeah.
Yeah, it certainly will.
Okay.
Oh,
You see that?
would the next one after that be 7? And would the next one after that be 7? I think it might be. But anyway, and this is the one where JAQ,
Yeah.
you could take and do square numbers, keep going, and see if the pattern continues.
Do you see that?
I had one girl that she found some patterns in 9s, and she took it out to 900. She multiplied 9 100 times, wrote them all out, and did it. And yep, there was cool patterns there. And again, I didn't tell her to do that. She just did it because she thought it was interesting.
Yeah.
And she learned all kind of stuff. Okay. And that's the idea. You want to get them to get some curiosity when it comes to the numbers. Okay. And we can also take a look. Oh, let's do this. Let's do this. Do you have a calculator?
Yeah, my phone.
Yeah, there you go. Perfect. This is an esoteric lesson. How to calculate square roots. Okay, these are not going to be totally accurate, but the bigger the number is, the more accurate it becomes. But let's find out. Let's say, JAQ.
Yeah, please pay attention to that.
Yeah, let's say I want to, what's the square root of 25?
5.
5. All right. So now let's say I want the square root of 28. I haven't done this lesson for so long. All right. I can look at that and I can see that, do I know that it's between 25 and what's the next square? 36, right? So I know it's got to be just, I know that it's, I don't know what it is, but I know it's somewhere between 5 and 6, right? Oh, that narrows it down. I know it's not 7. I know it's not 8. All right. So now I got to get closer. So here's what I want you to do. Take and look at your 5 square. Put your phone down. My God, you give it to him and immediately it's amazing.
Yeah.
All right. So what's the difference between, if you have your 5 square, there's your 25 square, and then I put my 6 square on top of it, that's going to be 5 and that's going to be 6, right?
Yeah.
So what I'm going to do is I'm going to say 28 is 1, 2, 3 out of how many? Well, this is going to be how many going around? You guys got to count. Look at it. Look at it. What's it counting around the 5 and the 6? So look at the 6. Yeah, there you go. Stop right there. And then, yeah. So can you see 28? Put a 3 there. Grab a 3. And just, okay, so now that's 28. So that's 3 out of how many?
Yeah, 6, 7, 8. That's plus the 3.
11.
Okay, so then I'm going to say that the square root of 28 is approximately, close, 5 and 3, 11. All right, now grab your calculator and let's check how close we are. So what's the square root of 28?
How do you do that on the calculator?
There should be a square root key somewhere on there. Turn your calculator sideways. Or turn your phone sideways. There you go. There should be a square root key that shows up.
No, but I wonder if I need to go to scientific.
Just, yeah, well, normally, what kind of phone is that?
Just iPhone. Oh, I see.
There you go. So if you turn it sideways, there's a square root key there.
I did, but it wasn't.
Uh-oh.
Is it the X square?
It should look like that.
Yeah, I know. I don't
or you might have to hit the inverse of the square.
Yeah, I see. Yeah, this is a weird calculator, man.
All right. Well, the other thing you can do is just mosey on over to Google.
Yeah. So square root of 28.
Yes.
It is 5.29.
5.29. Now I'm pretty sure your calculator can handle 3
Real.
divided by 11.
I think so. You have to close the door, guys, right now. Hold on. Close the door right now. Thank you. Close the door, please, Henry. 0.27.
It's not very close, but it's pretty close.
Yeah.
Right? We're only out by 2/100ths. Okay, so that's an estimation. And like I said, if we get bigger, we're going to get closer. All right. This right here. This appears nowhere on my website. This, like I said, this is a lesson that you don't ever get, Jack. You'll never see this in a public school. You can go to a college. You'll probably never see this. All right. So let's try again. Let's do another one. But see, we got close to 1 digit. All right. Let's make a bigger one. Because like I said, the bigger, the more accurate. Let's do, what if I want the square root of 67?
What two numbers is it in between?
Yeah. Give me the upper and the downer. What is it? What's the up? What's the upper? What's the downer? What's close? The square numbers. What's close? What's the square number before it and the square number after it? You got a thing right here. You tell me.
Do you understand the question?
What square is below?
These are all square root numbers. Yours is
What
some
square
number
is below 67? The
first.
closest square to 67, but below it.
49.36.
Closest to 67. Can you see a number on there that's
How
really
is that close to 67? How is that close? Which one's the closest to 67?
64.
There you go. 64. That would be 8.
above it?
All right. And then what's above it?
81.
There you go. That would, okay. So now we already know that it's going to be 8 and some more, right?
Mhm.
Okay. Now we got to know how many more. So let's see here. We're going to do 3 again, right? Out of how many? Well, I actually know it's going to be.
Jack, what's the difference between 67 and 64 where it's the closest to it?
3.
Okay.
Right.
that's the three.
Now 3, and then how much does it go all the way around? Count all the way around. I think it's going to be 8 and 9, which is going to be 17, but you count and tell me.
Total. You know what this
Yeah.
the blue one is? What is this? It's a 9.
9.
And then this way is also, this is an 8, and that's a 9.
Oh.
That's 18 total.
Yeah.
And
How much?
Respond to the question.
What?
3 out of how many is the question?
3 out of
Just let him count.
9. 9, but one is the same. So
Wait. It's not. It's 8 and 9.
yeah. That's 9 and 8.
17.
There you go. All right. Now punch your calculator and tell me what's 3 divided by 17.
3. Yeah. All right, save.
0.1764.
167.
Okay. So the 3 divided by 17 is 0. Point what?
176.
176. All right. Ask Google what the square root of 67 is.
It says 0.185. It's 8.185.
8.185. Oh, look at that. So now we're off by even less than last time. We're only off by not 0.009. That's, we're getting pretty close, right? That's 9 1,000ths we're off by. Okay, and then you could play with your calculator and get closer. But all right, that's the way to do it. Let's do one more and we'll quit. But like I said, this is esoteric lesson. But what are we doing? Every time, Mom and Dad, It's 45 add-ins, 400 math backs. I don't care about square roots. We're doing 45 add-ins and 400 math backs. And this is just an interesting way to do it. Oh, look, here's just doing add-ins in addition to our multiplication. All right, little boy.
Yeah.
Let's do kind of a big one. Let's do like, say, what's the square root of 109?
I knew it was gonna be bad.
All right, so what is it going to be between?
Have the list. Closest to that, but under. Closest to that, but over.
Yeah.
109.
So what would be the square that's
100.
all right?
And then
All right, so 100,
Which is what square root of what?
121. So it'd be 11 and 10. So we know it's going to be 10 and some more.
102.
Hold on, Crouton. No,
Yeah.
100 is a square root of what?
1.
What?
Again.
No, wait, the other way around. The square root of 100 is what?
Sorry.
Oh, 10 too?
10.
See, you're not interpreting it. You are seeing something and you don't know how to interpret it. So I'm trying to make sure that you actually comprehend, and you weren't.
'Cause this
10 times 10 or 10 square equals to 100. 10 in a square shape equals to 100. That's what that 2 is. It's not 102. So the question is, what's the square root of?
It's literally 102.
It's not
It's
102. It's 10.
10 to the second power. It's 9 to the second power. It's 11 to the second power. It's 5 to the that's not 52. That's 5 both ways. Like this is x both ways. And when we say x both ways, no, this is good. Because what? This is an x square. It's x this way and it's x that way. It's not just the edges. Anywhere along here, it's x. Anywhere along there, it's x. From here to here, it's x, and from here to here, it's x. Now, if let's make a little tiny one. Boom. This is just a 3 square, and now this is about notation, because he's right. It literally says 102, but the 2 is right. What is that? That's a 9 right there, right? And it's in a square. So I can write it 2 ways. I can say 3 times 3, and look at all that symbols. Or I could just say 3 squared.
Okay.
Okay.
So if you have 100 here, what 2 numbers you multiply by each other to get 100? 10 or 10 squared. So that's why 10 goes right.
121. What 2 numbers do I multiply to get 121? It's the same number. Right? 11. So now I know 109 falls between 100 and 121. This one's easy, that I know it's going to be 10 and 9 out of 21.
Here's your.
All right, so somebody get me a calculator. Jack, you got your phone right there. And punch 9 divided by 21.
But did he get to that difference on his own or no? Because I want to make sure he gets it.
Okay, I'm going to say no, but it should be pretty obvious that 109 is 9 parts of the way to 21, shouldn't it?
It's okay. The problem is not how to type things in a calculator. The problem is to understand what you're being asked to do.
Yeah, there you go. And then keystroke function is important. All right, so anyway, somebody tell me what 9 divided by 21 is.
9 divided by 21.
0.4285.
So it says 10.4285, right? Okay, do me a favor. Multiply 10.4285 by 10.4285.
10.4285.
Hold on, I did it wrong.
Yeah.
285 times 10.4285. 108.75.
Oh, we're not right. 108.75. Ooh, we're off by 0.25, right?
Mhm.
So, like I said, the bigger the number gets, usually the more accurate it becomes. But I mean, that's pretty close. Now, if I want to make it, now you can play with this. What would I have to do? And see, Jack, you could play with this. What would I have to do to this number to make it closer to 109? Well, obviously we're a little low, so maybe I could change that to a 6 or a 7, right? Or maybe I could change that 8 to a 9 and see what happens, just for fun. However you want to do it. And see, now it's just playing with numbers. And I know I've seen students, like, for an hour, they'll fool around with these. And then let's figure out, what would it be? What's the square root of 109, actually?
109.
10 wait, the square root of it. You need a calculator.
10.440.
440. So see,
Well,
we're
it's 03, but
okay. But see, we're close, but not close enough, right? But this is a way to estimate how much the square is. Now, there's ways to get more, but it's more math and more complicated than we need to do right now. But like I said, what are we doing? Just fooling around, and then getting to understand the over and the under. Right, we're close on either side of this number, and then being able to do the math in between, so on. So, like I said, what am I practicing? I'm practicing add-ins and multiplication more than I'm figuring out square roots. And if you want to get more accurate, you can figure out different ways to do it. But square roots have always been a problem, Jack, and that's why you'll notice that a lot of calculators, almost every calculator, has a square root key on it. And why do you need square roots? Well, there's all kinds of math where you need square roots. Calculating radius of a circle, right? It's r squared. If you're doing water flow through pipes, if you're doing all that kind of stuff, you need to know about square roots and squares. All right. What are you doing in school? What kind of, besides multiplication tests and so on?
I don't have the foggiest idea.
That's generally the case with most students. But what do you, besides multiplication, what are you doing?
Is it fractions, Jack?
No.
You're not doing fractions? How old? What grade? Technically, what grade is it? Fourth grade. So it should be mostly multiplication, probably some division. You're doing long division?
No. None of that.
Not yet. And it's at least it's good, because Irina, I'm not kidding. There are I've watched TikTok videos where they're teaching place value at fourth grade. And they're not getting it. And I'm just like, how do you not really okay, that should have been something that they had by the time they were 4 or 5, that you understand that depends on where the number is what it means. But literally fourth grade. Okay. So at least he's doing multiplication, which is about normal. Okay. And one more time, Jack, we're late on the multiplication. You should have been doing multiplication with 7 and under. So because we're a little late, that means you got to work a little harder, which means you got to spend a little more time at it. But you got to get to the point where the multiplication is easy. When I ask you, let me just ask you a couple of fast ones. What's 12 times 7?
Jack, don't get so scared. What's 12? That's 10 and 2. Multiply them separately and then add them.
There you go. I like it. There's that. So 70 and what? That's 10 of them. And I said 12. So you need 2 more.
4.
Because I said 12.
Yeah.
All right. So what are you going to have?
84.
Done. Okay. The point, Jack, is that it has to be fast and easy in your head.
Mhm.
All right. There are men and women, but mostly men, who absolutely don't want you to be able to do mathematics. These are not good men. Okay, they want to make sure that you grow up, and you can't do math in your head, because math informs, Jack. Math makes it so that if somebody's lying to you and you can do math, you can prove it. That's the other thing, Jack. It should, and especially your personality. If you can do math, the teacher can say 2 and 2 is 5. Doesn't matter. 2 and 2 is never 5. 2 and 2 is 4, and you can prove it. Same thing with multiplication. Same thing with a lot of algebra and right. If you can do math, there's no argument. We have never gone to war over a math problem because there's no argument. right? There's not in court. There's never been discussion, right? There is no controversy over mathematics because it's either right or it's wrong. Okay, now what they've done to most of our citizenry, they can't do math in their heads. Okay, all the good engineers, Jack, I'm not joking. I know engineers that can look at plans, build the thing in their mind, and tell you where the parts are going to wear out and where you need to make adjustments in the plans just from looking at the plans because they can visualize it. Okay, you got to be able to at least visualize this. What's that look like? Oh, it's like a brown square. What's that look like? Right? What's that look like?
Yeah.
Most of your friends have that's all they know about four. And see, when I was your age, and this is true, the first time I heard that's a square number, how the heck that got to be square? It's round, it's all bulbous. Why are you talking? How is that a square number? Because I thought it had to do with the symbol. I didn't understand it had everything to do with this. But I specifically remember asking my teacher, how is 9 going to be square? And he didn't show me this. He didn't have any of this. Right? And then same thing. How the heck is 16 a square number? That's all round too. Okay, because I was 9 years old and I didn't understand that it wasn't about the symbols. It's what the symbols represent. And it represents a shape that looks like this. That can be arranged. Well, let's see. That would be that one. Boom. Supposed to be a square. And oops. There you go. It's a big square. All right. It's that shape. It's a square shape. Okay. I might actually put this on my website someplace because, like I said, this appears nowhere on my website. I don't do the square root lesson. And like I said, the other thing with this is we're just close. We're not that accurate, right? But it's a good way to estimate what it is. Okay, I think that's it.
Yeah.
All right, Jack, you did a good job today. The only right. Okay, now we can quit, or I'm serious. Get your cups and play What's Under the Cup with your brother and your sister. And you, being the big brother, are the one that makes the problems. Right? Okay, and so the idea is that when you play What's Under the Cup, you're not going to solve the problems. You're just going to make the problems for your little sister and your little brother. Okie dokie. And then here's the other thing. Between now and the next time I see you, watch some more Multiplication Rock. Right? Just whatever songs you like, just watch the Multiplication Rock songs. Because the whole thing that he just did, like I'm very happy that you did that. They made you do the worksheet, but that's a test and that's it. That's not the teaching tool. That's just to see, oh, can he do it? And clearly he can do it. And not only can he do it, he can do it faster than anybody else in his class. Right? Then why is it? See, because this method works. It's not me. And it's the blocks and the method. Okay, so Jack, I think you're doing great. And we only have a few more classes, and then we're going to take a break over the summer, right? Okay. And then, and by then, like I said, you should easily be able to pay me because your silver will be worth so much money.
I don't plan on selling it. I have to. I have to.
No, there you go. You don't get. Yeah, exactly. Don't sell it for math lessons. Keep it and give it to your daughters and your sons and daughters.
Exactly.
All right, let me stop recording. CrewThunderMoon, salsamath.com for more.